Hi there, I'm Nix, and the topic of today's video is solving the reverse words in a string 3 problem on the LeetCode website. As always, solving this problem in C++ and giving you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of its time and space complexities, as well as looking at LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back. And I have a bit of explaining to do before we start, don't I? Yes, I do. In the previous video that I made, I went over Pascal's triangle too. Now this video is going over reverse words in a string 3. Didn't I forget something? Right, I did skip over reverse words in a string, but there is a reason that I'm doing it. I want to show you the solution that I have for this problem before I go over the problem that officially comes before it in this card. And the next video that I create is going to go over this one. So with that bit of explaining and foreshadowing of what's coming, let's go ahead and move on to solving the problem. We are given a string S, and we want to reverse the order of characters in each word within the sentence, and we want to preserve white space and initial word order. So with the handy-dandy example 1 here, we have a string that consists of 4 words. And the output that we want reverses each of the individual characters within that word, but the relative order of the words is still preserved. Taking a look at constraints here, we can have the string be very small or very large. We're dealing with ASCII characters, but the most interesting bullet points are the 3rd one and the 5th one. We don't have any leading or trailing spaces, and all the words in the string are guaranteed to be separated by a single space. And of course we have at least one word in S. With that said, how do we go about reversing these characters? Well, one thing to note is that they're always going to be separated by a single space. So we can use that white space character as a delimiter, in that once we see it, if we're looping through the string, we know what comes before is going to be a word, and we can start reversing the characters that we see between, say, the beginning of the string and the white space in this specific circumstance, or between one white space and the other white space within the string here. Now that's going to fall apart a bit once we get to the end of the string because we don't have a white space delimiter, but that logic is going to reverse all the words up until the last one. And then outside of looping through that string, we can simply reverse the last word outside of that. To accomplish this plan, we're going to need an integer variable to help track our position. Now with all that said, let's start moving on to the code. As I said, we're going to need an integer variable to keep track of one of our positions, because to reverse the words we need to know a starting place and an ending place, and the for loops index can serve as just one of those. So we need another one, and I just named it position and set it to 0. Next up is the for loop. Typical for loop starts at the beginning, goes until the end, increments up each turn. The first thing we want to check in the loop is if we have found a white space character. If we have, then we want to reverse all of the characters. And for this problem, I'm just going to use the built-in reverse function that comes in the standard template library of C++. In the rotate array problem, one of the solutions uses several reversals. And in that solution, I built a reverse function myself to be used within the problem. Did it all from scratch. So if you're curious as to what that code would look like, check out that video. I'll link it up in the corner here somewhere. But for now, let's just use this handy-dandy reverse function that's built in. Now to use the reverse function, you need to give it two iterators that point to the starting position and the ending position for where you want to swap characters. For this one, I'm using the begin iterator for both and shifting it to the correct beginning position by just adding the position integer to it. For the end position, again, I call the begin iterator, and then I add the index value to it. So for the first word, the position is going to stay at 0. The index is going to iterate up until it finds that white space. So reverse is going to go from, say, the beginning of the string all the way to the beginning plus index. So it's going to reverse all of the characters within this range, namely the wordlets, which is exactly what we want. After the reverse function has done its thing, we need to reset the position to the new location. Now, in order to set it so that s begin plus position is going to be equal to that white space character, we need to set position to the index value plus 1. This is due to the fact that we're in a zero index system, and sBegin is an iterator that points to before the official first character of the string here. So let's take this white space. We want this to be our starting position for the new word here that we're going to reverse. And this is at index 5. 0, 1, 2, 3, 4, 5. But if you add 5 to sBegin here, that's before even the first character, this is our starting place. We add 5, 1, 2, 3, 4, 5. We get our position shifted only to the L and not to our white space. So that's the reason why its position equals I plus 1. Now, as I mentioned before when we were planning this out, this loop is going to reverse all of the characters in every word in the string except the last one, because we don't have a trailing space that we're using. But that's a pretty quick fix. All I need to do is, after the loop finishes, I just want to reverse that last word. My position value, because of this line executing, is already in the correct place. I just now need to point the ending position to the point that is beyond the end of the string, i.e. just simply call the end iterator. This will reverse the last word in the string, and then our string is completely reversed and ready to be returned. So let's do just that. This is the complete code, and now we get to click buttons. So we get more judging, and we get exactly what we want. Every single thing is reversed, including the last one. Great. So if we submit this and subject ourselves to judgment, we get lovely green text. Excellent. Moving on to the analysis of time and space complexities. For space complexity, we have created an algorithm that is an in-place solution. We didn't create any new strings, any new arrays, nothing with variable memory. The only variable that we're using is an integer one that uses constant space, which means our space complexity is going to be on the order of big O of 1. For time complexity, we need to look at these for loops, and we need to look at this reverse function. The for loop is going to be determined by the size of the string that we're given, and the reverse function is going to execute commands to swap the characters. So the larger the word that is being reversed, the more time reverse is going to take, because it has to swap more characters. So we can say the for loop depends on the variable n, where n is the size of the string. The reverse loop depends on a variable m, which is the size of the individual word that is being reversed. And since the reverse function is being called within the for loop here, their time complexities multiply together, so we have a big O of n times m dependency here. This one adds another big O of m time complexity, but in big O we only care about the biggest term, which is dictated by this section right here. So big O of n times m time complexity. The last thing to do is click on this button to see our rankings, and we have a fairly high ranking here, fairly high range as well. That's interesting. Moving on to the range of the memory, which is absolutely huge. We have a fairly good ranking here. We're right near the top. Let's see if I can zoom in on this. It's better. So pretty good ranking for the memory usage, pretty good ranking for the runtime. But again, take the rankings with a grain of salt. That was how to solve the reverse words in a string 3 problem in an in-place way. And as we saw in the rankings, there are several other ways to do it. You could have used string stream, you could have carved out additional memory with creating extra string variables and so on and so forth. But I hope this solution helped you out a bit. If it did, consider subscribing. And with that, I will wish you happy coding and to have a nice day.